All right, good morning, everybody. I'm sorry I'm not with you guys. I just am not feeling very well, so hopefully I'll see you guys tomorrow. But I thought this would work. If I record this and you watch it and you pay good attention, you should still be fine because it's really me teaching you. So today's date, 10/18. I guess I need a better pen than that. Let's try again. 10/18. There we go. So our objective today really is to talk about inverse functions. Okay, not that hard. They're not that hard. Inverse functions. So an inverse is like an opposite. And in graphing, because we're talking about functions, when we graph any particular point, point A, any point has an x and a y value. If we want its inverse, I'll use the symbol -1. A to the -1 power represents, that's the symbol for inverse. When I see that symbol, I know I'm looking for an inverse. Okay, so what is inverse? It's really pretty simple. We've done it before. We're just going to switch our y and our x. So we have a point, all y's become x's, and all the x's become y's. Okay, so that's how you do an inverse. Okay. So define the following. Inverse of a graph. So the inverse of a graph is where all x values are the y values and the same, where all y values are the x values. Okay? So an inverse function, we have to be careful because sometimes you can have an inverse, but it might not be a function. So to have an inverse of a function, it must still pass the function test. Show you an example. Real easy example. We know, you know that this graph, y equals x squared, is a parabola. We've graphed that lots of times. We know how to do that, right? But if we wanted its inverse would look like this. Okay, so the inverse of this graph would look like this. That's a problem. That's a problem. That's the inverse. And that's a problem because this would not pass the vertical line test. So this particular inverse does not have a function. We'd say then that y equals x squared does not have an inverse. So we're going to say for right now, we're going to say that this graph, y equals x squared, does not have a graph. So it must pass a function test. Or, more specifically, it's got to be 1-to-1, or it must pass a vertical and a horizontal test. Horizontal test. So this graph, y equals x squared, would not pass a horizontal test, which means it would not have an inverse. I'll say this again. This graph does not have an inverse, right? Because that's not a function, right? Does not pass the vertical line test. So if any particular graph doesn't pass a vertical line test or a horizontal line test, it will not have an inverse. Okay? All right. Now, let's go back to points. So on points, if I have any particular point, point A has an x and a y, then its inverse is just to switch the y's and the x's. Okay? I'm gonna highlight that. Okay, I'm gonna highlight that. So if I take a look at these just points right now, I've got a point 5, 7. That's an x, and that's a y value. Then if I got the inverse of 7, now that's switching around the y, which means that its inverse would have to be the x. Answer is just 5. So I went from 5, 7, xy to switch. I want the inverse of 7, which is 5. That's all. Okay, this one's a little bit tricky, but it's not too bad because it's talking about the inverse and then the function. So if I go the inverse 7, we know the inverse is 7. Well, wait a minute. 7, the inverse has got to be its, if this is the y, it's the x, is 5. So if I want, so this became, one more time, f inverse of 7. So if the inverse is 7, go here. The inverse of 7 is 5. Okay, so that's 5. Then f of 5 is just 7. We see f of 5 is 7, okay? Okay. Now, how do we know these two are inverses? Well, let's take a look, okay? So first of all, I'm going to graph f of x. Okay, these two lines. Let's show their inverses, okay? So if I have f of x equals, and I'm going to rewrite this as a 1/2 x minus 1/2. It'll be easier to graph. And I've got g of x is equal to a 2x plus 1, okay? I'm going to graph f of x first. Let me see if I can get a different color. I always like colors. Colors are awesome. Okay, I got a color. Let's put this one in blue. I'm going to start at negative 1/2, right? And then my slope is up 1 over 2, up 1 over 2, up 1 over 2. Okay, there we go. Almost missed that point, but there it is. Okay, there it is. There's f of x. Let's graph g of x. All right, g of x, let's see, what color do I want to do g of x? I'll do it in, I got a green. Okay, I'll do g of x in green. So start at positive 1, and I'll go up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1. Okay. I'm graphing this one. How am I doing? Hopefully this is easy. You guys know how to graph points. Everybody knows how to graph points. If you don't know how to graph points, boy, we're in trouble. Now, here's something we know. A graph and its inverse are going to be reflections over the line y equals x. Okay, write that down. So a graph and its inverse, if these two are inverses, then they should be a reflection over this line, y equals x. Let's see, that's this line right here. Right? All right, so I'm kind of curious. I'm going to get some points here. So let's see, this point is at 1, 2, 3, 4, 5. Looks like about, oh, let's take this point. This point's easier. Go 1, 2, 3, 4, 5, 2. Okay, let's take this point here, which is at the point 1, 2, 3, 1. Let's take a look at maybe this point right here, which is, actually, how about this point, which is at 1, 2, 3, negative 2. All right, so the green line, let's see about the green line. It should have some points also. Well, it has a point right here at 1, 3. Has a point here at 2, 5. It has a point here at negative 2, negative 3. Well, look at this. Check it out. 2, 5, 5, 2. 3, 1, 1, 3. Okay? So they've switched all the way around, okay? Now another way we can prove it's going to be the same is if I take f of x and I want the inverse of f of x. So to get the inverse of f of x, I'm going to switch my x's and my y's, right? Okay, so f of x was a, well, let's see, let's rewrite it as a, y. I'm going to rewrite it as a y instead. Makes it easier. Y equals a 1/2 x minus 1/2. And now I said I want to switch x's and y's. So I'm going to switch the x and y variable. So if I switch the x and y variable, I'm switching all of the points. So switch x and y. So y becomes x, and x becomes y. And let's solve. Okay, so let's solve. So plus 1/2, I'd have an x plus 1/2 equals a 1/2 y. Oops, that's sloppy. 1/2 y. That's sloppy. And then if I multiply everything by 2 to get rid of the 1/2, guess what I'm going to get? I'm going to get, if I switch them over, I'll have a y equals a 2x, well, half of 2 is 1, and I get the same equation. So they have to be inverses. I know they're inverses for a couple of reasons. One, when I graphed them, the points were 5, 2 became 2, 5. So the points were switched. X becomes y and y becomes x. I also know they look like a reflection over the line y equals x. Okay, that looks pretty good. So they look like they've got to be inverses. And the last thing I did is I just actually switched the variables on f of x and solve for it, and I end up with g. So when I switch x and y and I get the same thing, it's got to be its inverse. All right, turn the page. Okay, now let's take a look at example 3. All right, if I graph this parabola, a couple of things I know about this parabola. We've done this before. We're going to start at 4. 1, 2, 3, 4. And I'm going to have to use a pencil for this. And you guys are going to find out why I'm going to use a pencil in a second. Let me grab a pencil. Be right back. Okay. You're going to understand why I need a pencil for this in a second. Okay, I'm going to graph this parabola. I mean, you can do it on Desmos, but if you want to know what this graph looks like, it really is like this. We've done it before. 1, 1, 2, 4, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and there it is. So I know my parabola is this, okay? However, here's the problem. The way it stands, the way it looks right now, it does not have an inverse. Is the inverse a function? We don't have an inverse because it's not a function. Because remember, it's like this one, right? And if you were to try and switch it around, it looks like this. So the inverse of this graph technically is going to look like this. Now, here's the problem. This does not fit vertical line test. So this does not have a function, or I'm sorry, does not have an inverse. Does not have an inverse. Can't, because when you take it and you draw its inverse, the inverse is not a function. Okay, so I'm going to erase this. That's why I use a pencil. I don't want that at all. That's not an inverse to get rid of it. So this, okay, so is the inverse function? No. But I have a little thing. Let's fix it. So I want this to have an inverse. It does not pass the horizontal line test. So it does not pass the horizontal line test. Okay, not at all. So what I'm going to do is this, domain change. I'm going to go back to my original graph. If I get rid of the back half of this graph, I'm just going to erase it. Get rid of it, okay? So this is the graph I really want to look at now, is this graph. I'm going to get rid of the back half and only have this part of it. So by getting rid of the back half, it will pass the horizontal line test. Okay, here's my dilemma though. You just can't erase. In math it says do a domain change. So I'm going to go say, all right, here's my f of x, which is equal to my 4 minus x squared. But I'm going to say, but I'm going to make sure that x is only greater than or equal to 0. Now that gives me the positive half. Here's my x-axis. So I only have this part. So now this graph will pass the horizontal line test, so it has a function. Now, we could go ahead and graph the inverse. So for instance, I know that this point is at the point 0, 4, so its inverse is at 4, 0. This point is at the point 1, 3, so its inverse is at 3, 1. This point's at 2, 0, so its inverse is at 0, 2. And so its inverse looks like this. That's our inverse. Awesome. And it does have a nice reflection over this line. Now, what's the equation of this line? Well, to find the equation, we're just simply going to switch x and y. To find the equation of the inverse, we're going to switch, write this down. All right? So, I had f of x, I'm going to write it as y instead. Instead of f of x, I'm going to write it as y equals my 4 minus x squared, and that's if x is greater than or equal to 0. That's important we put that in there because we don't want the negative half because it doesn't have an inverse. And I'm going to switch x and y. Right? So watch. Switch x and y, just go x becomes y becomes x equals 4 minus y squared. Okay, now we need to solve for y. Okay, all right, I can do that. Minus 4 x minus 4 equals a negative y squared. That's like a negative 1, so I'll bring over the negative. I'll just divide by negative 1 or multiply by negative 1, so I'll have negative 1x plus 4 equals y squared. I'll square root. And normally I'd have a plus or minus, but I can't. In this case, I'm not going to have a plus or minus. I'm not going to have two answers. We can't. It wouldn't be a function. So we're going to just say the positive part. It has to be the positive part because it is the top half of my, I don't need the plus there, but I put it in, of the square root, and I'll switch this around. 4 minus my x equals my y. Okay, that is the inverse, and I'm going to rewrite it like this. F inverse, I like that little symbol of x equals the square root of 4 minus x. Okay, that's all I have. Hopefully I'll be here tomorrow. Just don't feel that well. So anyway, here's your inverse. Here's your homework for tonight. Please work on it together and get it done, okay? That's all I have.